Ladies and gentlemen, welcome to today's lecture, which is lecture 3. In today's lecture, we shall be learning about the properties of discrete time Fourier series coefficients. The properties of discrete time Fourier series coefficients. Now, in order to determine the Fourier series coefficients, I mean the properties of Fourier series coefficient, let us consider two periodic functions which are discrete in nature to be x of n and y of n, and consequently let us suppose the Fourier series coefficient for x of n, which is c of k, and y of n be d of k. Now, upon these two functions, we shall try out and we shall try to determine different properties for the DTFS coefficients. Before going ahead, let me recollect the two equations, that is the synthesis equation in the calculation of the Fourier series, which goes something like this: x of n equals summation of n, where k goes from 0 to n minus 1, obviously n being the period of the signal. C of k is the Fourier series coefficient, e to the power j n k twice pi over n. And here the fundamental period, which is omega naught, is equal to twice pi over n. And consequently, the analysis equation which equals c of k equals to 1 over n, a running sum taken from n goes from 0 to n minus 1, x of n e to the power minus j n k twice pi over n. Now, let us go to the first property, which is the linearity property. Now, a system is said to be linear if any system, say x of t, which yields an output of x prime of t, and y of t, which yields an output of y prime of t. These two signal will be linear if we sum both the signals x of t and y of t and get the output to be equal to x prime of t plus y prime of t, which is also true if the signal is multiplied by a and b, where a and b can be considered as any DC values, and mathematically speaking, which are real in nature. So, as per the linearity property, if we take the signal x of t multiplied by a DC value a, and similarly y of t multiplied by the DC value b, and take their addition, the consequent Fourier series coefficient will also be multiplied by the DC value plus consequently the Fourier series coefficient will also be multiplied by the DC value as a sum. So what I mean to say is that if x of t and y of t are added, then let this signal be k of t, then the Fourier series coefficient of k of t will be, say, m of k, which is equal to c of k plus d of k. So I hope you understand the linearity property.